Alrighty, so we are now on example 3, and we're asked to show or prove that f of x is 1 to 1. So before we do that, we need to actually talk about the definition of 1 to 1, which I have written at the top, okay? So, to be 1 to 1 means if you have, we talked about if-then statements, okay? So yeah, when you have your if-then statements, you always start with the if, and then you manipulate your if to equal the then. So you can't just write the then. That doesn't work like that. So you start with the if, and if you can manipulate it to look like the then you have it, okay? So if a does not equal b, then f of a does not equal to f of b. That means that it's 1 to 1. Or if f of a is equal to f, not equal to, sorry, those are not equal to signs. And if f of a is equal to f of b, then that means that a equals b. So using this information right here, I'm going to prove example 3 to be 1 to 1, okay? So because we're proving, I'm going to use the equal sign. I feel like that's, I don't know, makes sense to me. I guess it really doesn't matter, but at any rate, it says if f of a is equal to f of b. So again, remember, we always start with the if then. We always start with the if, okay? So we are going to say that f of a is equal to f of b. We start with the if, okay? So now, how do we find f of a given f of x? Everywhere that there is an x, we are now going to write what? A. So I'm going to rewrite f of a as 2a minus 3. And I'm going to rewrite f of b as 2b minus 3. So now our goal is to simplify this equation and hope that it equals, that a equals b. And if it does, we have proved that it's 1 to 1. Okay? So from here, I'm going to add my 3 on both sides. And we get 2a is equal to 2b. The 2 is connected to the a by multiplication, so I'm going to divide both sides by 2, and we're left with a is equal to b. So it checks out. So that's how we prove that it's 1 to 1. There's also another way to prove whether something is 1 to 1, and that's on this board right here, okay? So here's another if-then statement. So if the function is 1 to 1, then the function inverse, so I know that this looks like an exponent. We talked about exponents being in the power, but this right here, we have at -1, is actually called the inverse, okay? So that's how we denote that. So if the function is 1 to 1, then the inverse is a function, okay? We also know that the domain of a 1 to 1 function is the range of the inverse, or vice versa. The domain of the inverse is the range of the 1 to 1 function. So you can actually interchange those, okay? And then lastly, this is what we're going to use for example 3. If, I forgot to write if. So if f of x is always increasing, then that would mean that it is 1 to 1. Or if it's always decreasing, that means that it's 1 to 1. So let's just think about our graph 2x minus 3. What type of shape is it going to make? It's going to make a line, right? So if we were to just think about the graph, we go down 3, 1, 2, 3, and then from there we go rise 2 and run 1, right? Because this is our slope. So our graph looks like this. This is constantly increasing, and because it's constantly increasing, we already know that it's going to be 1 to 1. So that's a simpler way to prove it. You know that this is always increasing, so it's 1 to 1. Or you could use the if-then proof from above.